Now we're going to do subtraction with negative numbers, and what we're going to do is simply define subtraction in terms of addition. That way we won't have any new rules to make up. So what I'm going to do is define subtraction as addition of the opposite. And the definition reads like this. If A and B are any two real numbers, that is positive or negative numbers, then A subtract B is always equal to A plus the opposite of B. So to subtract B, we always add its opposite, negative B. So here are some examples. 3 subtract 5 is the same as 3 plus negative 5. So instead of subtracting a positive 5, what we do is add a negative 5. Now I simply use my rules for addition. The two numbers have different signs, so I subtract the smaller absolute value from the larger. I get 2. The sign of the larger absolute value is negative, so the answer is negative. Negative 8 subtract 2. Instead of subtracting 2, I'm going to add its opposite, negative 2. Notice that my negative 8 in the beginning here doesn't change at all. It's simply the number that I'm subtracting that I add the opposite of. Now negative 8 plus negative 2, negative 10. 7 subtract 4. Well, there's a problem you already know the answer to. It's just 3. But if I write it this way, 7 plus negative 4, and then I use my rule for addition, you see I also get 3. So this is what subtraction is defined to be in mathematics. Subtraction is addition of the opposite. There isn't anything to debate or discuss about this. With a definition, you simply have to accept it. So A subtract B can always be written as A plus the opposite of B. So defining subtraction in terms of addition gives us the ability to use our rule that we have for adding positive and negative numbers. Let's look at our first problem. Problem number 1, it's 8 subtract 6. Okay, I don't want to do any actual subtraction, even though I know the answer to this is 2. I want to rewrite it as 8 plus negative 6. So instead of subtracting positive 6, I add its opposite, negative 6. That gives me the correct answer, 2. Now, I already knew that answer was 2. This just justifies my rule a little bit more. You see, my rule is consistent with what I already know about subtraction. But what the rule allows us to do is to subtract more combinations of negative numbers. Negative 4 subtract 1 is negative 4 plus negative 1. So instead of subtracting a positive 1, I add its opposite, negative 1. And that comes out to be negative 5. 3 subtract negative 9 is 3 plus positive 9. So instead of subtracting negative 9, I add its opposite, positive 9. I'm doing the same thing with every problem. I haven't changed my method one bit. Just because the numbers in the problem change, that doesn't change what I do. Every time I've changed from subtraction to addition of the opposite. Now, 3 plus 9 is 12. Negative 10 subtract negative 3 is negative 10 plus, instead of subtracting negative 3, I'm going to add its opposite, positive 3. So instead of subtracting negative 3, I add positive 3. Negative 10 plus 3, negative 7. Now the next problem I want to do is a simplify kind of problem, so let's look at it. I have negative 8 plus 3 subtract 4. I'm going to write this as negative 8 plus 3 plus negative 4. Just to write it all in terms of addition. Now negative 8 plus 3 is negative 5 plus negative 4. Negative 5 plus negative 4, negative 9. So negative 5 plus negative 4 comes out to be negative 9. Now, you're not always going to write this step right here where you change to addition of the opposite, but you are always going to think in terms of addition. I never think in terms of subtraction when I do these problems. When I look at a problem like this, even though I'm not going to show any work with it when I do it myself, I say to myself, negative 8 plus 3 plus negative 4. I always think in terms of addition, even if it is a subtraction problem, because subtraction is addition of the opposite. Here's our next problem. Negative 7 subtract 3 subtract 6. If I'm thinking in terms of addition, I'm going to think of this problem as negative 7 plus negative 3, which is negative 10, plus negative 6, which is negative 16. So the answer to that is negative 16, and I can get that even without showing any work simply by thinking in terms of addition. Negative 7 plus negative 3 plus negative 6. Now let's look at some problems written in words. Let's subtract negative 3 from 8. So I'm going to take 8 and subtract from it, there I'm introducing my own subtraction sign, the number negative 3. So here I am subtracting negative 3 from 8. Okay? Instead of subtracting negative 3, I'm going to add its opposite, positive 3. That's 8 plus 3. And the answer to that is 11. So subtract negative 3 from 8. The answer is 11. Now remember when we said at the beginning of this section that you have to be careful about trusting your intuition when it comes to these arithmetic with positive and negative numbers? It's especially true with subtraction. Your intuition might tell you that subtracting negative 3 from 8 might give you 5 or negative 5, something like that. It doesn't. Subtracting negative 3 from 8 gives you exactly 11. Here's our next problem. Subtract negative 6 from 5. 5 subtract negative 6. Well, that's going to be 5 plus 6, which is 11. So subtracting negative 6 from 5 gives us 11. Let's look at a problem now that involves the word difference. Find the difference of negative 7 and negative 3. Well, I know when I see something written in this form right here using the word difference that I always have to subtract in that order. The difference between negative 7 and negative 3 is negative 7 minus negative 3. In all these word problems, I have to introduce my own subtraction sign. So here is the difference of negative 7 and negative 3. That's negative 7 plus 3, which is negative 4. So the difference of negative 7 and negative 3 is negative 4. What we want to do next is look at another problem that involves words. What number do you subtract from 5 to get 8? So what number do you subtract from 5 to get 8? So 5 minus what number is going to give us 8? What number do I subtract from 5 to get 8? The answer must be negative 3, so that I can get 5 plus 3 when I change to addition of the opposite. So the number I subtract from 5 to get 8 must be negative 3. Here's a word problem. Felicia has a balance of $68 in her checking account. When she writes a check for $37 and then another check for $53, write a subtraction problem that gives the new balance in her checking account. So I have $68 for the balance. I want to subtract from that the amount of the first check, $37. From that, the amount of the second check, $53. Now, if I'm working this problem in terms of addition, that's 68 plus negative 37 plus negative 53. Now, if I work this problem out, this is going to come out to be negative $22. So the balance in her checking account comes out to be negative $22. So you see, this is a realistic application of subtraction with negative numbers. If you have a balance in your checkbook of $68, you write a check for $37, another check for $53, you're going to end up with a negative number for the balance in your checkbook. So what you want to do with subtraction of positive and negative numbers is just work enough problems so that you see that subtraction is addition of the opposite, and you find yourself thinking in terms of addition even when you're doing subtraction, and you're consistently getting correct answers.